Hello calculus students and seekers of truth. In this video we will continue our study here of particle motion calculus, and we are going to continue with the vocabulary here, except we'll look at a particular case of a function. So a particle is moving along a horizontal straight line. Let the positive direction be defined as moving right and the negative direction be defined as moving left. Let s of t be the position of the particle at any time t. So we've given some sort of direction here. Positive means to go right, and then negative, we know that means to go left, right? And this is the position function of the particle. So the displacement of the particle between t equals 1 and t equals 2, well, that's given by the change in position. Remember that the displacement is the change in position. So, not too surprisingly, this would be represented as s of t2, the position of the particle at time t2, minus s of t1, the position of the particle at time t1. Alright, let's keep going. The average velocity, remember, average velocity is the change in position, or the displacement, over the change in time. So this we can represent as s of t2 minus s of t1, all of it over t2 minus t1. So this is, again, really just a slope equation. Let's continue. The particle is moving to the left when? Okay, so this is a bit interesting. How do we know that the particle is moving to the left? Now, you could say that, perhaps you could say something like s of t is negative, right? But that isn't really correct. That's very intuitive, but it's actually not correct. So let's talk about this a little bit more here. The particle is moving to the left really when the velocity is negative. In other words, whenever the velocity is towards the left, that's when the particle is moving to the left. So when the velocity is negative. And the way that we represent velocity, you remember, really instantaneous velocity is the derivative of the position function. So this is the velocity. Whenever the velocity is negative, then that's when the particle is moving to the left. And of course, we could add on to that when the velocity is positive, so that s prime of t is greater than 0, then the particle is moving right. That means the particle is moving to the right. Okay. So be very careful here. S of t only tells you where the particle is. It doesn't tell you how the particle is moving. All right, number 4, s prime of t2 minus s prime of t1 over t2 minus t1. So these quantities here, s prime, these are the instantaneous velocity, or we could just say the velocity at those particular points. And when we're subtracting the two, we're getting the change in velocity. So this is the change in velocity over the change in time. So of course the answer here is acceleration. But we have to be very careful. It's not the instantaneous acceleration, it's the average acceleration of the particle between t2 and t1. All right, I'm going to end this video here, and we'll start one last one with the vocab when we talk about the speed of the particle. So that's a little bit more interesting as to know when the speed is increasing or decreasing. But hopefully what this video and the previous ones have done is laid a foundation for you to use this vocabulary